Please open in your learning workbook to page 166.
Let's complete some example problems. All right, here's an example for us to solve. Determine whether the functions are inverses. We have f of x equals 100 plus 12x. We have g of x equals x subtract 100 all divided by 12. Okay, so what's the process to determine whether two functions are inverses of each other? We compose both functions together in both directions, and we need to get the result x both times. Let's begin. Let's begin by composing f with g. So this is f composed with g of x, which equals f of g of x. Now, our variable here is x. It's a variable, not a number, so we're going to work from the outside in. That means the next line that we write is going to come from function f on the right-hand side, this. But instead of x, we're going to write g of x. So we get 100 plus 12 g of x. All right, now we know for this problem, g of x is equal to this fraction, so that we have 100 plus 12 times x minus 100 all divided by 12. Now we're going to simplify. 12 is the same as 12 over 1, which means this 12 is in the numerator and this 12 is in the denominator. So those are both going to cancel to 1. Anything times 1 is itself, anything divided by 1 is itself. So this just becomes 100 plus x minus 100. The 100s cancel, and we're just left with x. So what we have shown is that f composed with g of x equals x. That's half of the journey. Now we have to reverse the direction of the two functions and compose them in this order. G composed with f of x, which equals g of f of x. The input is a variable, so we work from the outside in. We start with function g, specifically on the right-hand side of function g. This is what we write next, but everywhere you see an x, you put f of x instead. So we get f of x minus 100, all divided by 12. Now substitute. We know that f of x is equal to 100 plus 12x. So we get 100 plus 12x minus 100 over 12. The hundreds cancel, which gives us 12x over 12. The 12s cancel, which gives us x. So g composed with f of x equals x. Now we can draw our conclusion. Because f composed with g of x equals x, and g composed with f of x equals x, therefore we may conclude that f of x and g of x are inverses of each other. Okay, let's try one more example. H of x is equal to the cube root of the difference x subtract 1. K of x is equal to negative 1 plus x cubed. The question is the same. Determine whether the functions are inverses. Okay, so the first thing we're going to do is we're going to figure out what is h composed with k of x. First, we rewrite using the definition, h of k of x. The input is a letter, a variable, so we work from the outside in. We're going to use function h, specifically the right-hand side of function h. But everywhere we see an x, we're going to put k of x instead. So we'll have this. Now we know what k of x equals for this. It's negative 1 plus x cubed. So we get negative 1 plus x cubed minus 1. All right, now we simplify. Minus 1 more, that's minus 2. So we get the cube root of the difference, x cubed subtract 2. This does not equal x. And because of that, we may state that h of x and k of x are not inverses of each other. The moment you get a result that is not x, you can stop and draw your conclusion.